Question 1. Um, let's read it first. In a competitive labor market, demand for workers is given by this demand equation. Right, so let me just change to drawing. So that's the demand equation. And supply is given by this equation. Right, where Q is the quantity of workers employed and W is the hourly wage. So what is the initial equilibrium wage and employment level? So let's draw the demand and supply diagram. On the y-axis we have wage, and on the x-axis we have quantity of labor, which is basically number of people. Right, so let's put this as Q here because it's denoted as Q, yeah? Right here. I was going to say L, but that's Q there. So I will not draw this. I won't draw this schedule, but I will just sketch. I will just sketch the demand and supply lines here. So given the wage 10,000, so that's something like this, let's say, and the supply is something like this, let's say. So this is the supply of labor and this is the demand for labor. So let's label them L and D. Oh, sorry, S. Yeah, so this is supply. I'll use conventional labels. This could be sort of other labeling as well. You could choose any other letters that's convenient for you. Now that's that equilibrium is for price, or let me put this down as W as well because that will be more consistent. So let's do this. So that's equilibrium wage and equilibrium quantity of labor. So this is the number of people employed at the initial equilibrium wage. Now numerically the solution is when quantity supplied along this supply line equals quantity demanded, right? So equating these two equations then would give us this. So 10,000 minus 100 W equals 2,000 plus 1,900 W. Now the unknowns are going to be on the left side, so I will move them to the left hand side by subtracting 1,900 W from both sides, and also taking away 10,000 from both sides of the equation. So that will give us 100 W minus 1,900 W equals, now this is 2,000 minus 10,000. Yeah, because I subtract 10,000 from both sides. Now this will leave us with 2,000 W, and this is 8,000. Negative sign. So now W is basically 4. So that's 0 there, yeah. $4. So this is the equilibrium wage. So what is the employment level at equilibrium wage? So at that wage level, the equilibrium is found by plugging this result into either this equation or this. Doesn't matter which one you plug the value in. Basically it will give you exactly the same thing because the same number, or it will give you equilibrium quantity because at the equilibrium point here the quantities supplied are equal to quantities demanded. So let's use the demand equation. So quantity demanded is 10,000 minus 100 W. I'll just rewrote this equation, take away 100 times, now if you plug in W, which is the equilibrium wage, the 4 into it, then you have 9,600 people. So this is the number of people at the moment employed at the wage of $4 per hour, I suppose. Yeah, that's $4 per hour. So it's dollars per hour here, and that's the solution to this part. So the next part is this. Suppose that the government decides that $5 per hour is the minimum allowable wage in any market. How would this new minimum wage alter the market? Now, this is something called price floor, or the minimum rate that the employers will be required to pay the wage, so they cannot pay less than that. So this is legally binding requirement. Essentially, this is illegal. It will be illegal to pay less than this wage. Yeah. Now, since it's $5 per hour, the wage rate that they have to pay will be above the equilibrium level, yeah, by $1. So it's greater by $1. So let's draw that line. So let's say this is 4 here. So roughly, this would be the line for $5 minimum wage. So this is the price floor in a way. This is the wage floor, the minimum wage. Yeah. So this is wage equals $5 here. Then you have points, 2 points here that are crossing the supply and demand lines. Now, how would this alter the market? Now, as you can see, this creates extra supply of labor in the market. So, yeah, let me just remove this so that I have more space. So if I trace this here and trace that here, so we have now quantity demanded at that wage level. So this is $5, yeah, and maybe I'll just replace this with 6. Oh, sorry, 4, and yeah, this is 9,600. Yeah, 9,600, and this would be labor supply. So this is the number of people are willing to work for that $5 wage rate, and this is the number of people employed at the wage rate. Okay, so that creates, actually, given the excess supply, that creates surplus of labor in the market, basically. More people, so this is surplus. This is how it affects the market. So how, given the high wage rate, higher than average equilibrium rate, there will be more people willing to supply their labor in the market. So that's how it alters. So there's a new equilibrium wage here in the market. Now, what would be the new employment level then? Well, as I said earlier, employed people would be found by equating or plugging. Actually, I didn't say that, did I? I just simply mentioned that this would be the number of people employed. Yes, number of people employed are along the demand line, because demand now is represented by not the consumers but by the employers, firms. So firms employ at the $5 wage rate. Yeah. So where the price line crosses the demand line, that's the employment level, right? So to find now employment level, we will use $5 wage rate and plug it into the demand equation here. Yeah, so that should give us the employment level now. So that's now, let me solve that then. Quantity people employed would then be new employment level, 100 times 5. So the employment level, new employment level, is now 9,500. So that is the number of employed now people. Earlier, if you recall, this was the original employment level. The initial employment level was higher, yeah, at a lower wage. Now, because now wages are cost of production, and cost of production increased by the wage increase, by the amount of wage increase, then fewer people will be employed. That makes sense, right? And in fact, now this gives us 100 people unemployed, basically. Yeah, this yields 100 people who are now unemployed or lost their jobs. Okay, so that's that there. And another thing here we would like to find out is, according to this question, what would happen to total payment to labor? So that's what we want to find out. Payments to labor now. Now, originally, payments to labor were at $4 per hour. Now that rate increased and employment level changes. So we will now multiply this and work out the payments, amounts of payments. Let me do this. I need space, so let me move this way. Payments to labor, initial payments, so at the initial equilibrium, payments were, so let's say payment 1 was $4 times how many were employed? 9,600, yeah? So that is $38,400. That's the total payment on the initial equilibrium level. Yeah, so with the initial equilibrium level, we had $4 and that many people were employed. Now payment 2, after this rise in the level of wages, employed people were 9,500. This is now 47,500, yeah? Right. So payment to labor have increased, yeah? Payments to labor have increased. There's more now being paid. So that's an interesting result here, guys. Fewer people lost jobs, but because the increased wages, higher increase in the wages meant that there will be excess payment apparently. So that's the result. Now, would there be any excess supply of labor? Yes, but we didn't calculate that, yeah? So that's the second question within that question. So will there be any excess labor? So let's work that out. Excess labor, is it? Yeah, supply of labor, yeah? So we mentioned that, but we didn't calculate that. So labor supply. Now we will use the, let me do this. We will use the demand and supply equations to calculate excess labor or shortage. We'll see. It is excess, yeah? It's this surplus of labor. Now we'll use the demand line and supply line and plug $5 in each of them. Yeah. From previous calculation, we know what the demand is or employment level is, 9,500. That is when we use the demand equation. Now for the supply equation, we will just copy the equation again, 2,000 plus 1,900 W. Just to make sure that I copied this correctly, yeah? So that's the same, yeah. Okay, so now 2,000 plus 1,900 times, what's this? 5. Now this will give me 2,000 plus, so that's 0,059, yeah? So 9,500 plus 2,000, that is 11,500. That's it. So that's the labor supply when the wage is $5. But the labor demand at that wage rate is 9,500. So the surplus will then be 2,000. So this is 2,000. The excess supply is 2,000. And notice this. These 2,000 people who are looking for a job includes 100 people who lost their jobs. Remember? Because at the original equilibrium, this was the number of people employed, 9,600. Now with the new wage rate, employed number of people is, if I state it here, would be 9,500. Yeah, here. So 100 people lost their jobs. They are in this 2,000 people group. Basically, they are part of this people looking for job now. So in addition to 100 people who lost jobs, there are 1,900 extra people who are willing to work but are still looking for jobs. So that's the unemployment level in a way, yeah, if that makes sense. Right, so we've done that. We've completed this question. So this is the second question now. Oh, let me just correct it slightly. Okay, so this is the second question. Now, if demand for show tickets is described by the equation, okay, and supply is given by this equation, find the equilibrium price and quantity. So let's solve this first. Best way to start demand and supply equation, so diagram by basically, or sort of problem, by basically drawing the demand and supply equation first and then working through solution. If we can visualize it, it will be easier to solve and understand, and it would also give you intuition as well, better intuition as well. So that's price at equilibrium and quantity at equilibrium. So this is the initial equilibrium. Yeah, find the equilibrium price, it says. So we need to find what P star is and Q star is. So we will equate quantity supplied to quantity demanded. That is then 100 minus P equaling 20 plus P. And if you just move the unknowns to the left side and constants to the right side, we will now have 2P equal minus 80. P then equals 40. That is the price right there, it's 40. The quantity in equilibrium is then, we will now plug price into one of these equations. Let's put this into demand, doesn't matter which one you choose. So that's 100 minus 40, then you have 60, right? So let me save that space for the next part. That's done. So that's 40 here, sorry, 60 here. Next, so that's equilibrium quantity. How would your answer change if the supply curve shifted to QS 10 plus P due to increase in actor salaries? Okay, so this is supply 1 then. Now, because actors' wages increase, this would be higher cost of production, yeah? That usually has a leftward shift effect on supply, so it shifts the supply to the left. Let me do this properly then, because it has a positive intercept. It's somewhere here. So shift happened, but it's just to the left. Yeah, so, and this value means the supply line crosses the x-axis at point 10, while this is a point 20 here, right? Given this result here, or the intercept, yeah? So these are points. The intercepts here are on the x-axis. Usually they are on the y-axis, but because our y-axis here in the equation is, usually this is the equation. Yeah, let me just cast it differently. So this is y equals a minus bx, yeah? So y in this case is quantity demanded, x is p, b is minus 1 here, and a is 100. Yeah? Similarly, it's the same here. Y in this case is quantity supplied, a is 20, b is 1, and p is x. Yeah, so that's that there. It's just a shift of supply then to the left given this new equation. This is S2. So the new equilibrium here is this point right here and this point right here. Let's work this out. We will equate quantity demanded to new quantity supplied. Yeah, new QS prime. Right, demand didn't change, demand line stays the same, it's just this line is now our new supply line, supply curve. Okay, so that's 100 minus P equals now to the old, new supply P. Now moving P's to this side gives us 2P. This is 90, yeah? Or you can simply just take away P from both sides and take away 100 from both sides at the same time. P would then be $45, so that's the rate, yeah. Now ticket price, yeah, by the way. Then we will then use this price in either this equation or this equation to work out the quantity in equilibrium. Doesn't matter which one, I'll just use the supply equation, which is basically quantity demanded still, yeah, because at equilibrium they are the same quantities. That's 10 minus P, sorry, plus P it should be. So that's 10 plus 45, 55 tickets sold. Okay, so that's the equilibrium price and quantity, and that's the solution to second question. Now the third equation, or I should say third problem. Suppose the demand for onion ice cream is described by the equation, okay, good, so that's the demand equation, and the supply was described by this equation, okay. What are the equilibrium price and quantity? Show your answer using graph. So we need to draw the graph, not just sketch, I suppose. So let's draw up a schedule for demand and supply. So when the price is, let's say, a certain quantity, what are the values? Yeah, let's say. So this is quantity, let's say, demanded, and this is quantity supplied. Right, we'll start with, say, prices 0, 5, 10, 15. No, that won't help. I changed my mind, sorry. It will take ages apparently to do that. Let me do this. Let's solve for equilibrium quantities and figure out how we can sketch it. I'm finding it very interesting that they are negative values, so we'll figure it together. Yeah, that's the fun part of it. In equilibrium, quantity supplied must be equal to quantity demanded, as you know. So let's solve this by equating. Minus 40 plus P equals now 20 minus P. We have 2P equaling, what's this? 60, P is $30. Okay, that's interesting, $30. Because this has this negative intercept that makes it slightly sort of odd looking supply curve. That made me rethink my first initial sort of attempt. Now let's plug this into any of these equations and see what happens, and let's take this supply line. It doesn't matter which one you choose, supply equation or not, so let's take supply equation. It's basically 40, negative 40 plus 30, okay, 10. Quantity, this is negative 10, right? That is weird, isn't it? Basically, at this price, nothing is sold, basically, because you can't really unsell products, or what to call it. In fact, what's happening here is, I have no idea, but what we can say is this, from an economist's point of view, the quantity in equilibrium is zero, because if you draw this, let me draw this now, this is where it starts making sense to you as well. Quantity here, price is here, so all values on this graph should be positive, because we start off from 0 and everything here would be positive, so 10, 20, everything, and here as well from 0 to onwards is positive. We won't have negative, let's say 10 in quantity. If it is negative 10, this has to be on this quadrant, yeah, it has to be, let's say this is minus 10 here, this has to be there. So if we were to draw these lines starting with demand, let's say this is 10 here, this is 20, then demand is somehow something like this. I guess That's too much. That will be too high, I mean. So let me draw it again. You can draw this using a schedule, but something like this, would it help? Yeah, probably that's better, yeah. This is the demand line. This is quantity demanded, or simply, let me put this down as D. If you were to draw this using a sketch, that should be the result. Now supply then is has an intercept on the quantity and minus 40, so the intercept would be somewhere here. Let's say this is minus 40, let's say, yeah, on this quadrant. So if you were to draw the supply line, it would have to be something like that. It would have to be something like this. This is supply, yeah. But notice that we do not take into account all this. We do not think of this at all, because this part is negative quantity part, so we will not be doing this, focusing on this at all. So ignore that part. Let me remove this part completely. So that will be technical side of when you're drawing these lines, yeah. This is, but economists do not take that into account. That quadrant, the negative part, this part, doesn't make sense for an economist. So this is supply, so we'll only consider this side. This is the correct supply line. Now as you can see, because the demand and supply lines do not cross at a positive quantity, there is no equilibrium in this market. So that this is the meaningful result for this solution. Or economists would consider that prices change, but supply demand do not cross. So from a technical perspective, and from a sort of analytical perspective, or so if you put it into a context of this situation, there is no equilibrium price, or sorry, there is no equilibrium quantity. That's what I wanted to say, yeah. Because demand in this case lies below the supply curve at all prices, or meaningful prices, I should say, yeah, where output is positive. The reason is, if we were to continue this, let me draw this again further. If we were to continue this, they will eventually cross. And this part here, well, it's not exactly what I chose initially, but it is minus 10 here. Yeah, minus 10. Yeah, I put minus 10 here, but that was a mistake apparently, because of my drawing, shape of the drawing. Now I had to change that. So this is the negative quantity, but because economists deal with positive quantities, we ignore that. Yeah, a few people ask me, I mean, students ask me about these in the past, constants. We do not usually look at them. They are just mathematical construct. They will make sense only if we draw and try to impose some sort of assumptions on the results. And in this case, this market doesn't have any equilibrium quantity. Yeah, it doesn't. I mean, equilibrium. There's ice cream sales there. People sell ice cream, but there's no equilibrium basically in this market. That's all. Yeah. Okay, so that's it. I hope this is clear. Now this is question 4, or problem 4. If demand for toy drums is described by the equation and supply is given by this, find equilibrium price and quantity. Okay, so equilibrium is when quantity demanded equals quantity supplied, as before. So that's 300 minus 5p equals 60 plus 3p. Now solving for p, then you have 8p equals minus 240. Yeah, take away 300 from both sides of the equation, and we have now p equaling $30 per drum. Okay, and equilibrium quantity is then plug $30 into either of these equations. So let's use demand times, so that's demand equation here. P is 30, so that's P times 30. Yeah. Now quantity in equilibrium then is 150. Okay, so that is the equilibrium quantity. If we were to draw it, we will then have supply somewhere here. Say this is 60, yeah, given this value here, and here is maybe here 300 given this in the demand equation. So that will be our demand line. So this is supply, this is demand. This is a sketch, yeah, just eyeballing this, and we know that right now it's $30 and 150 here. Okay, not to the scale, guys. This is not to the scale, yeah. So that's the equilibrium price and quantity initially. Now, how would your answer change if a decrease in consumer income shifted the demand curve to new place? So that's 220 minus 5p. Now, shift of demand. When incomes decrease, as you know from our classes, incomes declining means demand will shift to the left. So that's somewhere here is our new income, demand line crossing the quantity axis. So that's 220, yeah, so that's this here, 220, and it's a parallel shift. This is D1, this is D2. Now, what is the new equilibrium price and new equilibrium quantity? So let's work this out. We will use the same supply equation because supply didn't change. So that's 60 plus 3p using this formula. And the demand equation is new demand now, yes? So that's 220 minus 5p. Right, collecting the unknowns, so that's p, 8p equals now, moving or taking away 60 from both sides of the equation, we will now have 160 here, and p would then be 20. That's an interesting result. Yeah, that would be correct, but this is a big decline, isn't it? Well, the 10-pound decline, sorry, it's a 10-pound, not much actually. So that it's not a big fall. So that's that. Price is now 20. That's not bad actually. And now quantity, new equilibrium quantity is, then we can use either of this demand or supply equation, yeah, demand equation or supply equation. So that's 220 minus 5 times 20 pound or $20. So that leaves us with 120. That's the new equilibrium quantity right here. Right, so decline in fall in income reduced the equilibrium price because people tend to buy fewer items now, or in this case drums, because of their reduction in income, in their income. So that led to the quantity sold in the market to fall. Okay, that's it. That's the solution. Question 5. This is an interesting one. So a new chemical cleaning solution is introduced to the market. Initially, demand is given by this equation and supply is given by this equation. Okay. Determine the equilibrium price and quantity. What we do here, we will solve it as usual. Let's draw the graph quickly. Let's assume that this is our initial supply and this is our initial demand curve. Initial equilibrium for quantity and price are given there. Okay, so let's find what they are, their values. Right, that's 1000 minus 2p equals 100 plus p. Now collecting the unknowns on the left hand side, we have 3p with the negative sign, and subtracting 1000 from both sides of the equation, we will now have minus 900, and that is price equals $300. So this is the initial equilibrium level of price. Quantity now, so we'll find by using the demand equation, 1000 minus 2 times 300. So I plug 300 into the P and I have 400 units. So initially that is the equilibrium price and quantity. Now the government then decides that no more than 300 units of this product should be sold per period and imposes a quota at that level. Okay, how does the quota affect the equilibrium price and quantity? Show the solution using a graph and calculate the numerical answer. Well, I've already drawn the graph, but this is not going to be the right graph for that second part because there is quota. So the new supply line, there's a new supply line now. So this is, let's say, without the quota, let's put this as just S. Now with quota, we have an upper limit of quantity, so that is 300 units. So supply is going to increase up to the point where we have reached the quota level. So this is, let's assume this is 300. Then it will have this vertical line. This is basically supply with quota. So supply will not go any further. So it's just vertical line at any price basically, because that's the limit, yeah, that the government imposed on the quantity of this chemical to be sold in the market. Yeah. Now the question is, how does this quota affect the equilibrium price? Now the equilibrium price will then be where new supply line, which is basically this sort of supply highlighted in blue, crossing the demand line. So this is where this new equilibrium quantity and prices are. We already know what the equilibrium quantity is under new quota system. That's 300, so that's the maximum sold. Under free equilibrium, free market equilibrium, we usually would have 400 units sold and bought. But because of the restriction, it will reach the maximum basically. Yeah, this quota will be met at 300 points. So that's the equilibrium quantity for us. We cannot basically sell more than that or buy more than that. Now, at what price are these 300 units sold? Well, that is then we have to find it, yeah, by using the supply and demand equation. In this case, we'll use the quota values on the demand equation, because quota supply equation or supply quota is basically the quantity that can be sold or quantity that can be bought as well. So that is also the quantity demanded. That's the maximum amount. Yeah. So let's draw this or solve it. The demand equation, as you know, is 1000 minus 2p. Now with the quota, now we replace QD, yeah, with the amount of quota. So that's 300 equals 1000, right? And moving the unknowns to the left hand side, we have 2p, and subtracting 300 from both sides, we have 700. The new price is then, that's the new price at equilibrium, is 350, isn't it? Yeah, 350. So it was 300 when market was free. Now it's now intervened, so there's government intervention in the market and they imposed the quota of 300, and price as a result, given the limited amounts, price has increased. New price level is now 350. So that's it. That's the solution to this problem. Next is question 6. Here is an interesting question. Demand for park visits is, so demand for park visits is 10,000 minus 100p, right? Okay. Now, if park visits are free, how many visitors will attend? Well, when they are free to go, we have price equaling 0, right? So quantity demanded will then be 10,000 minus 100 times 0, which is basically 10,000. That's it. So that's the free entry visitor numbers. What if there is an admission fee? It's not free. Basically, you pay to go there and enjoy. Now, it says show using a graph. So, okay, so let's show using a graph. This is quantity, this is the price, and demand looks something like this. Let's assume I'm sketching this, and given the admission fee is fixed at 220, this will be a straight line, horizontal line here. This is $20 price line, and the equilibrium quantity of visits will then be, or number of visits will be, where the demand line crosses the price line, $20 price line. So this is the equilibrium quantity. So how do we find it? Well, we will just plug 20 into demand equation. Yeah, and this will give us 8,000. So if, sorry, just realized this is not dollars. There's no dollar sign. It's the number of people, right? So 8,000 people will visit the park if it's not free. So that's that. So that's the solution to this question.